everybody to the CERV Smart Ventilation webinar today. My name is Ben Newell from Build Equinox, and we'll be talking about CERV Smart Ventilation. And as I mentioned earlier, feel free to send questions in at any time. Alex will stand by and answer them, and if there's time at the end, I'll answer some questions as well. As far as the outline of topics we'll cover today, the current ventilation standards we'll cover briefly. Smart ventilation, answering what it is. Take a look at CERV Smart Ventilation System. Look at Service, which is online data collection. A little bit of the CERV versus an ERV versus an HRV, and then just a summary of the main points. Current ventilation standards, which many of you are familiar with, ASHRAE 62.2 is what you hear quite a lot about these days. And looking at that in comparison to smart ventilation, it's important to note that the ASHRAE standards are just an agreed upon minimum ventilation standard, that it is not an indoor air quality standard. So a lot like building codes in that there's minimum codes and requirements to ensure a certain level of safety and performance. That's exactly what the ASHRAE 62.2 standard is. It's a minimum standard to ensure a certain level of ventilation, but it isn't indicative necessarily of an indoor air quality that you'll see in the home. So some of these limitations of the standard are that the airflow rates prescribed through the standard are based on some old odor detection studies, not on air quality. The nominal 20 CFM per person airflow rate that comes out of these standards will equate to an average CO2 level of above 1,000 ppm concentration. It obviously doesn't account for higher pollution events or occupancy changes in the environment. Treats gas and electric appliances the same, so there's no distinction between those two within a home. So an all-electric home versus one with gas, water heater, cooking, things of that nature. And so new studies coming out, and kind of our motivation for developing the CERV and smart ventilation are that the new studies show that the 62 standards are inadequate to reduce impacts of poor air quality on health, cognition, and sleep quality. So even though 62.2 is prescribing a certain airflow rate to introduce fresh air into the home, this isn't enough to avoid reduction in these effects on occupants. So what exactly is smart ventilation then? It's taking measurements of these different pollutants in the home, comfort conditions like temperatures, humidity, perhaps other things, and then making operational decisions based on these data along with the user inputs and set points. So why is this important to do? Well, you can't control what you're not measuring. So if you're trying to control the air quality in a home, much like temperature or humidity or these other things, unless you're actively measuring them, that there's not much you can really do about them besides just guessing and hoping that on average maybe you're doing an okay job. So this allows you to ensure a healthy and comfortable environment inside the house. And then you can account for changes in occupancy, different living activities in the home, pollutant levels. So you're not treating all homes the same, modeling them all the same, ventilating the same way, that each home is treated differently because each activity, occupancy, and these things in a home is different. And then, of course, you can save energy by just ventilating to what's needed in each house. Now, CERV Smart Ventilation then helps set the new standard for superior air quality. Measuring temperature, humidity, CO2, VOC levels, to get a sense of what's going on inside the house so we can actively control it by introducing enough fresh air. We can automatically account for these changes too. So the CERV is what's the smart system doing all this work. you're not having to monkey around with different settings. You have control over these different things, but it should be really taking care of things behind the scene and merely providing you with the information to know that things are being kept in control. Now, an important distinction, as I mentioned the odor study before, that the ASHRAE standard is really based upon the high VOC and CO2 levels occur much sooner than indicated by discomfort or odors would indicate. So your nose is really a poor indicator that the air quality in your home is not very good. So by the time you are able to detect this, you're well above the levels that you should be keeping. Measuring what's going on in the house then can adjust for infiltration rates by opening doors and windows or other things. And then we can optimize for energy conservation. Some things we're working on are more preventative ventilation as well. So where you see the Nest thermostat or things that can react to your schedule as it builds up over time, we can do those same predictive and preventative ventilation in a home with smart ventilation. And we can use the data to provide feedback in the way of reports or other things to the user that things are being kept under control, and also feedback in how you can improve the level of air quality in your home. So it's kind of an ever-evolving thing as well as you do capture this data. The impacts of smart ventilation, much like home builders and architects and homeowners, they build homes that exceed code for various reasons. So they want a home with better comfort, better energy efficiency. They want it more durable, reducing the life cycle cost of the home, and then perhaps making it more marketable so it's easier to sell or commands a higher price in the marketplace. Smart ventilation then has similar effects. So where you could just ventilate to ASHRAE standards, buy a ventilation system that will meet the airflow that's prescribed there. Smart ventilation really takes you to that next level, and it's really the equivalent of building a high-performance home. Now you have a high-performance ventilation system. So it does all the above things in terms of comfort, efficiency, durability, saving costs, making your home more marketable. But then it also obviously will improve health, cognition, productivity in the home, improve sleep quality. And then because you have proof of the indoor air quality, that's an important thing too, that people want to know, hey, is this thing doing what it should be doing? And having that proof is a very, very valuable tool. To put it in perspective of what the energy costs versus the health costs are within a home, if we think about the entire housing stock being high performance, that is roughly 4,000 kilowatt hours per year per person, figuring about 12 cents per kilowatt hour, that the annual cost for energy for homes is about $160 billion per year. About 80 billion of that is for the people loads in the home, and then about 80 billion to condition a house due to the climate, keep them comfortable. If you look at that figure and compare it to the annual cost of influenza in the United States, you can see about half of that total energy cost for homes is the impact that just flu has each year. So 87 billion a year spent on the flu is not an insignificant number. We know from studies that improving the ventilation will reduce concentrations of these things that can spread the flu, and that you can so that's an important distinction there, that reducing health effects that way is quite a big load on people medically. Asthma is another part of this. So 10% of the population now is impacted by asthma, so about a third of households. This results in another $56 billion per year. So again, something else we know that improved air quality in the home can impact. Can reduce that down to 5% where it used to be, or even more with smart ventilation. These are things to be seen. Poor air quality, again, as you spend most of your time indoors in your house, there's a hangover effect. So reduced sleep quality and these other things that as you leave your house and go to work, you're still dealing with the effects of poor air quality. Just a 1% reduction in productivity is $500 per year if you assume roughly $50,000 salary job. So again, quite a big cost when you're comparing this all to energy, which seems to be the main focus in green building these days. That with smart ventilation, the impacts are pretty substantial in terms of not just the health and wellness, but the economic impact as well. And it's just as great as energy. Taking a close look now at the CERV system in particular, this is the base system shown here. It is UL listed, and we're proud to say it is made here in the United States. It was designed and built here by us at Build Equinox. And our facility is 100% solar powered. If you follow our newsletter, that was our most recent newsletter article was on that transition to being a net zero plus facility right now. The base system here that we see, the control module, part A, or part B, excuse me, has the dampers and the sensors and smarts. All the electronics are built into this. The heat pump module does the energy recovery, is located here, part A. The two inline fans, exhaust and supply fans, and then the touchscreen controller. Looking at this is a schematic of those same components, kind of showing internally what's happening there. So you can see, much like a standard ERV or HRV, there's two inputs and two outlets from the unit. There's a return air to the unit from the house, a fresh air from outside, and then on the outlet side we're supplying air to the inside of the house and then exhausting air outside of the house. The part B I mentioned has the two sides to it with two bidirectional dampers. And then down below is the heat pump module here with the hot and cold side of the heat pump. And the touchscreen controller is the user interface that goes along with the system. So as far as the part B, then the control module, just getting an even closer look at that. This shows the inlet half and the outlet half of that. So the bidirectional dampers can either be in a vertical or horizontal orientation. That will connect either these two ducts and these two ducts, or in a horizontal orientation will connect the horizontal ducts together. So that gives the CERV the different degrees of operation, where it can be in fresh air ventilation mode or recirculation mode, both in either heating or cooling modes. The sensors then that are built into it are the independent CO2 and VOC sensors for the air quality. And then we also measure the temperature and relative humidity of both the inside as well as the outside air. The heat pump module is what allows us to do the energy recovery. So it's through the heat pump cycle, unlike conventional ERVs and HRVs. This allows us to either heat or cool and dehumidify the incoming fresh air before it's brought into the house. And then we're exchanging energy as the outgoing exhaust air is sent outside of the home. The heat pump is hermetically sealed, so there's no refrigerant charging needed for the system. It's sealed for the lifetime. The compressor is out of the appliance industry, so it's virtually silent, extremely efficient. We use a digitally controlled inverter drive compressor, so that gives us variable speed and very efficient heat pump. And then there's no low temperature operation, so there's no preheat or other things necessary to operate at low temperature conditions. The CERV is fine with well below freezing temperature, unlike most other ERVs and HRVs. Just to give you an idea of kind of how the air is moving through the system in these different modes of operation, this shows then the inlet half and the outlet half of the Part B control module, and then the heat pump down below. In ventilation heating, what is happening is we're taking air from the inside that's going through the inlet half of the control module, which sends it down to the cold side of the heat pump. So we're actually extracting heat out of the inside air before that's exhausted to the outside. On the outside fresh air coming in, that's directed down to the hot side of the heat pump, where it's brought up in temperature before being supplied inside to the house. Likewise, in recirculation mode, which if you don't need fresh air, the CERV can spend time in recirculation mode, which helps to even out the air quality in the home as well as the comfort. And the CERV can use its heat pump rather than purely energy recovery. It can provide a small bit of heating or cooling and dehumidification to the space. So in this mode of operation, you can see that the inlet half of the control module has gone to the vertical orientation. So now the air from inside is merely circulating over the hot side of the heat pump and being supplied back inside. So this is like a conventional forced air heat pump system. And at the same time, we're taking fresh air from outside, we're extracting heat from that and sending it over the cold side, so it's leaving the house colder than it came in and being sent back outside. So in this mode, while we are bringing fresh air into the house, it's just heat's being extracted and it's being sent back outside. Comparing that to like a mini split heat pump that has an outdoor unit, think of that being shoved into an insulated box that you still need outside air to move over it, but in this case, both of those inside and outside components are within your house. Cooling mode operation is similar. You can see here the inlet half is vertical in the ventilation cooling. The outlet half is horizontal, so we're taking outside fresh air. That's being cooled and dehumidified before being sent inside, delivered fresh air to the home. This is important, especially in humid locations. So the southeast United States, down south, concerned with humidity, that we can cool and dehumidify the fresh air before it's brought into the home to reduce any impacts of it on the house. At the same time, then we're taking inside air that's going over the hot side of the heat pump. We're heating that up and then exhausting that outside. So that's what's doing the heat rejection, taking the heat out of the fresh air, cooling that down, and that's being sent outside. And then recirc cool is just like an air conditioner. So we're able to cool and dehumidify the house in this mode if fresh air isn't needed. On average, from what we see, a CERV may spend maybe 25% of the time in ventilation mode versus 75% of the time in either recirculation or just sitting off in standby mode between assessment periods where it moves the air in the house to get a sense of what's going on. The supply fans are inline fans, so one is supplying air to the house and the other is exhausting it outside. Serve as a balanced ventilation system, so when it is in vent mode, one fan is bringing air inside while the other fan is exhausting air outside. In the recirculation mode, the fans are separated then, so the one fan is circulating the outside air over the one side of the heat pump, and then the inside fan is circulating over the other side of the heat pump. They're variable speed ECM fans, so they're super efficient and quiet. We have speed control over these, so during different events, we can have different airflow rates depending on the needs. For example, boosting the airflow during a triggered ventilation event. As far as filtration goes, there's no filtration built into the CERV itself. We offer some different options as far as inline filters. One would be placed on the fresh air intake from outside. Reason to not build this in the CERV is that we want that fresh air filtered as soon as it's brought into the house. So where most equipment may be in the mechanical room, centrally located in the house, we want to keep as much of the ductwork coming into the house clean as possible. So if we can put that inline filter in a convenient location close to the exterior wall where we're bringing fresh air in, that's more beneficial than being built into the central system. Likewise, a return air filter will filter the air in the house, and this also we like to be able to place this in a convenient location to do frequent filter changes. CERV just uses then standard filters, 10 by 20 or 12 by 20, typical sizes, so you don't have to buy special filters from us. You can use whatever filtration level you're comfortable with. We offer MERV 13, which are extremely high filtration levels. And then you don't have to clean it. They're not filters that you clean. These just become really dirty over time. They actually become sources of pollution rather than helping to filter the air. So it's important to have filters that you can just discard and don't have to worry about that type of maintenance on. The user control, the interface is a wireless touchscreen controller here. All of the sensors for the CERV are built into the unit, so this controller can be placed anywhere in the house. It communicates wirelessly with the CERV. You just have to plug it into a wall somewhere. So it's a color touchscreen. We've kept in mind that we should keep the interface easy to read, so the screens are large and icons are large and numbers and are easy to read. Also the levels and how you get through different settings, we've tried to keep that to a minimum, so you're not going to get lost in the navigation or have trouble changing different settings. So that was very important to us as well as we developed this. This shows just the home screen here in a little more detail. You can see here this is what's happening inside the house, temperature and humidity. This outside, or more accurately, is what's coming into the CERV from outside. So there can be a little offset there depending on the length of ducts and insulation level on the ductwork and that. Looking at the CERV's screens a little closer, just kind of an overview of where you control different things. As they're showing in the last screen, the home screen here is just kind of shows what's going on in the house, the current mode of operation here. This is a status bar here, just showing it's connected to the CERV, and then what other things may be going on. This icon, for instance, shows that a wireless switch has been pressed, and so it's ventilating a bathroom or kitchen, for example. The main menu then is here. Click on that, getting here, and that takes you to the main control screens for the CERV. So from comfort, then you get to the air quality settings, CO2 and VOC sensors. They share the same set point. We haven't seen a reason to have them with independent set points at this point. And then schedule ventilation. The most energy efficient way for the CERV to operate is just demand control. So it's sensing what's going on and ventilating when needed. But if you'd like to set a schedule ventilation on top of that, you can do that. Heating and cooling set point. That's what's telling the CERV whether in ventilation mode or recirculation mode, whether it should be heating or cooling the air coming in. So you set both of these together. There's a cooling set point and then a heating set point. Anywhere in between that, then the CERV may just bring fresh air inside, or it may activate the heat pump despite being within this range if outdoor conditions are pretty extreme. So if it's really cold outside but heating and cooling set points are satisfied, it's going to bring the heat pump on to boost the air temperature up and do that energy exchange. Under CERV, then, this is where the main system configurations happen. Auxiliary device, if you wanted to activate a heating or cooling system, or maybe there's a backup or larger ventilation system, the CERV can control all those things, as well as some different options as well. ECM fan settings, operation mode, assessment interval when it's taking readings to see what's going on in the house. Looking at some options that can be purchased along with the CERV. Geo-Boost is a ground source heat exchanger. This converts the CERV kind of into a hybrid air source geothermal heat pump. So just connecting it to a simple ground loop of plastic tubing. A lot of times people will just put this in for new construction around the foundation of the home. Roughly 150, 300 feet of loop is sufficient for that. And then you'd have a circulating pump that the CERV would be controlling. So it allows the CERV to maintain efficiency and boost capacity during extreme hot or cold weather. So this will precondition the air before it gets to the CERV. And the CERV's doing this automatically too, so it's sensing whether it's beneficial to run this or not. And especially in the wintertime, this can add a significant amount of heat to the home without then expending much energy. So 30-watt circulating pump getting 1,000, 1,500 watts of heating is a nice boost for the CERV. And as a heat pump system, then that's energy you're actually seeing in the home as conditioned energy relative to an ERV or an HRV that is using that merely for frost protection. So that's just kind of a new starting point for those systems. That energy isn't actually being sent into the home. So that's a distinct difference in how the CERV can make use of a ground loop as opposed to conventional systems. Wireless switches here can be used for bathrooms and kitchen venting, so spot ventilation, eliminate bathroom vent fans. These then trigger the CERV to ventilate for a certain period of time, so the user sets the time length they'd like the CERV to ventilate, and whenever those switches are pressed, then you can actively ventilate during those times. Zone control is something that is kind of developing right now. We just have a simple zone where the CERV will switch between one of two zones for a period of time. And for local codes, will mostly dictate how this may be used in a multifamily type setting. But for larger homes or different kinds of homes that may have maybe an apartment built into them or something like that, that the CERV can look at these different regions separately and switch zones. Something that should be releasing fairly soon is our mini split control. So this will give the CERV the ability to control a mini split within a home. We see these paired quite a bit with the CERV, where the mini splits are doing the bulk heating or cooling for the house. The CERV is doing as much as it can, but this just gives more integration of the two systems together so that the CERV can make use of that when necessary. One of the most important options, and just to further make use of smart ventilation, is what's called Service. This is our online gateway. It connects the CERV to the internet. This gateway up here, it simply plugs into your router. There's no service fees, so as long as you have internet, it'll work. Connects the CERV online. You can control it from anywhere on your phone, iPad, computer, or other device. This allows the CERV's software to be automatically upgraded online. You can view historic data for your house or export that data. You can see what's been going on over time. And then our new analytics section provides metrics based on the indoor air quality of your home. So this is what's really powerful in providing that user feedback that your home is being kept at a good level. And then we can show you how the level of air quality in your home is impacting different metrics in terms of your health and cognition and things like that. This is some more detail of just kind of how that data looks online. If you haven't been to our website, there's a demo of service up there. That's showing actual data for Equinox House. So you can click through the controller screen to get a feel for how that operates. And then you can view and download data if you'd like. But there's temperature, humidity data, there's CO2, VOC data for the home. This is just showing the air quality. So you can see CO2, VOC traces here. The green shaded background is indicating when the CERV is in ventilation mode. So for this data set, you can see the CO2 level rose above set point, triggering a ventilation that brought it back down. This may have been a high occupancy level here, and then eventually went back down and ventilation was no longer required. Just another interesting feature of the CERV and showing it through service data here. This is temperature and humidity data along with the air quality. This is swing season data for free cooling. So times like now where you may, high performance homes especially, where it's nice and cool outside, but you may want to start cooling inside. The CERV can just bring that fresh air inside to both recharge the house with fresh air as well as do that free cooling. So there's no energy exchange, which is actually bad in this case. You don't want to exchange any energy. You just want that fresh air brought in as it is to provide the most capacity. And so this is just a snapshot of this occurring, where each night as the temperature was falling, the CERV was going into vent mode. The green, I think, is the temperature. So as you can see, as that falls, it's going into vent mode. These are the air quality levels here in the home, so you can see they fall. And then that should then eliminate needing to ventilate during the daytime when it's not going to be as favorable to bring in fresh air. So this can impact the house quite a bit in terms of air quality levels as well as energy efficiency. Obviously, measuring air quality, you can detect things that may be going on that shouldn't. This is a new house that has gas appliances, and they're seeing quite high VOC levels. And they had the gas company come out and found that their gas dryer had a leak in it. So that was repaired here, and you can see then the VOC levels drop down after that. So obviously there's some really bad things that can happen in your house that you would otherwise maybe not know are going on unless you are looking at that data and able to record that. The service IAQ metrics I mentioned, and these are actually covered in another webinar that we offer periodically. These you can go on our website under the news section to view this webinar, IAQ metrics. This is what is new on service, and this is providing feedback to people on how their air quality levels are impacting their health, cognition, and sleep quality, comparing that to baseline ASHRAE 62.2 levels. So if you were ventilating to where there were no degradation in these things, comparing that to the baseline, so how much better can you be than the ASHRAE standards for ventilation? So that gives you that feedback as well on a week-by-week basis. You can look at that over time. Looking at CO2 versus VOC domination, so Is the house seeing higher CO2 or VOC levels on average? These are some different metrics, and then just kind of average CO2 and VOC levels over time here as well. So what kind of homes or locations in that is the CERV beneficial? The air quality in homes is the same whichever type of home you're in, a large home or a small home. The characteristics are fairly similar, but there can be a wide range throughout the day or between just occupants and their activities in a home. So the CERV is really a system that is built to handle anything in between. So a small 500 to a 1,500 square foot manufactured home versus 4,000 square foot custom homes that people need good air quality, and so the CERV is able to handle anything in between and exceed the ASHRAE standards in any of these cases. Ducting wise for the CERV, typical ERV or HRV ducting applies here as well. We recommend pulling from the green areas, the bathrooms, kitchen, laundry areas, anywhere that will be producing pollutants. So CO2, VOC, moisture, and odors, things of that nature that you want to exhaust outside. So where those may have the highest concentration, and it's applying to the living areas and bedrooms. This is just kind of a schematic of a duct layout in a home. Typical ducting then about 4 to 8 inches on the return, uninsulated, and then some level of insulation on the supply line. Again, 4 to 8 inches, the typical diameter, depending on the duct layout. And then it can either be dedicated ducting. We do like to see the exhaust ducting dedicated to the CERV, to those locations. The supply then can be shared with, say, a forced air system or something of that nature. Looking at the CERV, comparing it more to conventional ERVs and HRV systems, the one and done systems just are not effective. They lead to poor air quality, poor air circulation in the home. They're also much lower flow rate. So where all these try to meet the minimum standards of the ASHRAE 62.2 level, it's just insufficient to maintain what we know is good air quality. 40 CFM into a house with 2 people, you'll be well above 1,000 ppm on average. So when people are there, it's going to be much higher. When you're gone, maybe it's lower, giving you on average about 1,000 ppm. And then in individual spaces too. So if you have 2 people in a room where you're only putting 8 CFM, the CO2 concentration is going to rise above 3,000 ppm. The other thing these one and done systems do, because they can't recirculate air throughout the home, it's going to prevent conditioned air from making it into certain spaces. So this is especially detrimental when trying to use ductless mini splits or even ducted mini splits where you don't have forced air into those rooms necessarily at a high capacity level. That supplying fresh air into a bedroom is going to prevent any of that conditioned air from coming through the doorway. You're going to have a net outflow of air into that room. And because an ERV or an HRV is always deconditioning that space, those bedrooms are going to be at a state that's either above or below the comfort conditions, depending on the season. Also looking at the IAQ trends of just a conventional ERV versus what a CERV smart ventilation can do. This is some actual data from a very high performance home with a high-end ERV system in it. Obviously they don't know what the air quality level is in the home. They've just been told to set it to a certain level, and that's okay by code. But as we can see here, when the house is occupied, they're well above 1,000 ppm on average. This is a time period when they were away for a weekend. And you can see that's when the air quality is at an acceptable level. And then coming home again, then it's insufficient fresh airflow to maintain that. So without taking this data, there's no way to know how to set your ERV to keep the proper airflow. Just comparing that again to the CERV representation of how that's working and tracking the airflow and ventilating when you are hitting that set point and bringing it back down. Climatic zones for the CERV. We're lucky here in developing it in central Illinois that we have about the worst weather you could imagine. So we have really cold and dry winters, like those you see up in Canada and Vermont. And then in the summertime, we're extremely hot and humid. So we get some of the same weather they do down in Louisiana and Texas and Florida. This just shows kind of the comfort level where people feel comfortable in pants and long sleeves or shorts and short sleeves inside a home. So you can see much of our weather is not where you just want to open windows and bring in fresh air. You're going to need to do energy recovery and condition that air before it's brought inside. So this has been a good test bed for the CERV. But it works well in any of these regions just because we are able to go to extremely low temperatures without any problems, as well as cooling and dehumidifying that fresh air before you're bringing it inside to reduce any impacts on the house. These are some examples of different homes around the country that are CERV projects. We work a lot in passive homes that require, obviously, mechanical ventilation. LEED Platinum, the same thing. Intermountain West out in Colorado, Geo-Boost is I think one of the largest net zero neighborhoods in the country are using CERV systems there. Deep retrofit passive solar house here in Colorado, and then this is actually the first certified passive house in Denver here. Vermont is really pushing standards as far as energy. Air quality is also at the top of their list, so they're not just looking at green building as being something where you're trying to reduce energy in these homes. They're very aggressive also in making sure that these are more healthy and comfortable as well. So this has been a big market for us. Northwest and Southeast then, as I mentioned, regions really concerned with humidity. So Carolinas, Florida, Georgia, Tennessee, quite a bit of interest in the CERV from that region. And then Portland, Seattle area, they have quite a unique climate there where they need dehumidification along with heating generally. And so the CERV able to do that with a heat pump. We've seen quite a bit of those kinds of projects in that location. In terms of energy versus URVs and HRVs in the CERV, this is an energy model we did, 2,000 square foot home, 0.6 ACH, so a very well sealed home, very well insulated, R48. And we've made a few assumptions here as far as where to keep the air quality level, 900 ppm, and then we had an HRV of 90% effectiveness with a certain airflow rate here and fan power, and then an ERV with 80% heat and 60% moisture effectiveness. These are actually pretty high numbers assumptions here, but we wanted to make sure we were having a good comparison with the CERV. So you can see for two people here, the CERV is more efficient overall in terms of the energy over the course of a year, but it's not a huge difference. You can see that people load is a much greater difference in energy than just comparing the different systems and how you're ventilating. How does that energy trend compare around the region of the U.S. The C is the CERV, H is HRV, and E is ERV. You can see where the ERVs and HRVs kind of bounce around depending on the climate region. But the CERV in each of these climate regions is more beneficial than those two systems. So no matter where you are in the U.S., you don't need to decide whether one system is better than the other. Yeah, the CERV is better efficiency. Just summarizing then, smart ventilation overall is needed to maintain air quality levels and to truly maintain it at a healthy level. That occupants are sacrificing health and comfort, energy and money by ventilating just to meet code. So there are really a lot of benefits to going above what is just needed. And that's the main reason that people are choosing to build above code. And now with the CERV type of ventilation system, they're able to also ventilate above that code as well. There's no reason to sacrifice fresh air for different, for cold outside air or different humidity reasons. That you always want to have your ventilation system able to maintain full ventilation capacity. And then also, smart ventilation allows it to adjust to pollutant levels and activities in the home automatically. And then as we saw in all climate regions, all types and sizes of homes as well, that a flexible smart system is able to handle all that. I mentioned the webinar on IAQ metrics. These are just some other ways to keep informed and educate yourself further on air quality and things. Our newsletter, you can sign up for that. It's just a monthly newsletter on different topics and spotlighting different projects as well. So education is important to us as well. On our news, on our website under news, as I mentioned, that is where you can find that webinar. It has the video and the slides along with that, and we periodically do a live demo of that as well. And of course, contact us with us. Any questions or for more information at any time, we're happy to talk with you. And we appreciate you taking the time to learn more about smart ventilation and the CERV in general. If there are any other questions, I'm happy to answer them. It looks like Alex has done a good job of answering them as they've come in. So happy to answer any more as we have time. All right. Well, looks like we've gotten all the questions. So again, thank you very much, and we look forward to hearing from you soon. Thank you.